Hi guys, in this video we'll be looking at Legendre equation, which is another method in solving power series. Let's go. We have y. Let's write out the trial series. It's the same method as Frobenius. As Bessel, I still using the same method. A0 plus A1 x plus A2 x squared plus A3 x cubed plus AR x to the power half. It might be A4, X4, A5, x to the power 5, and so on. Now before we continue, let's open this bracket. So we're going to have y prime multiplied by 1, we have y prime prime minus y prime multiplied by x squared, we have x squared, y prime minus 2xy plus k multiplied by y, that's ky, multiplied by k. To open the bracket, we're going to have k square y plus ky equals to 0. Why this, open this, why this, then open this, we have this. So let's open the bracket, because we have three types of y: normal y prime, y prime, y prime prime. Now let's obtain our y by using it to open the bracket. So we have a0 x raised to power c plus a1 x raised to power c plus 1 plus a2 x raised to power c plus 2. There's no need to write a3, so we have ar x raised to power c plus r. Now to get y prime, let's differentiate this. We have a0 c x raised to power c minus 1 plus a1 c plus 1 x raised to power c plus a2, then we have c plus 2 x raised to power c plus 1 plus ar c plus r x raised to power c plus r minus 1. Y prime prime, again to redifferentiate this, we have a0 c minus 1 and x raised to power c minus 2 plus a1 c plus 1 c x raised to power c minus 1 plus a2 c plus 2 c plus 1 x raised to power c plus ar c plus r c plus r minus 1 x raised to power c plus r minus 2. So that is the first thing to do. Now let's substitute this into this equation. So the first one is y prime prime, which we're going to rewrite a0. Please, yeah, you have to rewrite and you have to follow this order. Follow the order of the equation. Plus a1 c plus 1 c x raised to power c minus 1 plus a2 c plus 2 c plus 1 x raised to power c plus ar c plus r c plus r minus 1 x raised to power c plus r minus 2. Now, the second one is minus x squared y prime prime. Now we have to multiply y prime prime by minus x squared. So which means that every x's that we have here, this 2 is going to affect all the x's there. So you're going to have minus a0 c minus 1 x raised to power c. This 2, that means we'll be adding 2 to this, to the power of the x's, minus a1 c plus 1 c x raised to power c plus 1 minus a2 c plus 2 c plus 1 x raised to power c plus 2 minus, it's also minus ar c plus r c plus r minus 2 minus 1, then x is power c plus r. If I add 2 to this. For the second one, next one we have minus 2xy prime. So we have minus 2xy prime. We are multiplying our y prime, this y prime, by minus 2xy prime. Now this x here is raised to power 1, so it will be affecting all the x's that we have. We're adding 1 to them. So we have minus 2 a naught c x raised to power c. When you add 1 to this, minus 2 a1 c plus 1 x raised to power c plus 1. Now the next one we have minus 2 a2 c plus 2 x raised to power c plus 2. Now we're adding 1 to all the power of x6 minus 2 ar c plus r x raised to power c plus r. Now when you add 1 to this, it will eliminate. Now the next one we have k square y. This is our y. We are multiplying everything by k square, so which we are going to have a naught k square x raised to power c plus a1 k square x raised to power c plus 1 plus a2 k square x raised to power c plus 2 plus ar k square x raised to power c plus r. Now for the last one, which is ky, we are multiplying everything by k, y by k, so we have k x raised to power c plus a1 k x raised to power c plus 1 plus a2 k x raised to power c plus 2 plus ark x raised to power c plus 1. So these are the values that we obtained. Let's take it one by one. Now the coefficients of the first x that you're going to take will be from the first one, which is y prime prime, and this is a list. So the next part is that we are taking the coefficient of x raised to power c minus 2. Please, when you want to take your own, don't take it from any other one. That's why you have to write it orderly. Once you did not write it orderly, you are going to miss it. So you need to write it orderly. Start from the first one that you have. This is the first thing that you have. So it's the first equation that you have that you're going to pick your x from, and this is the least one that we have there. So if we check through, it is only here that we can find x raised to power c minus 2. So that's only what we're going to write out. C minus 1 equals to 0. So whereby a naught cannot equals to 0, so it will now be c over c minus 1 equals to 0, whereby c equals to 0 and the other one equals to 1. This is the value of our 2c. This is the value of our 2c. Now the next one, we can see here that it is only this place. If we check through, we have c plus r, c plus r, c plus r, c plus r. But here we have c plus r minus 2. So we are going to change it there. I'm going to change this one. So we have ar c plus r, c plus r minus 1, x raised to power c plus r minus 2. Now you have c plus r minus 2. We want c plus r, so we need to add 2 to it. So now say let r equals to r plus 2, because we need to add 2 to this. So anywhere you see r now, it's now be ar plus 2, c plus r plus 2, c plus r plus 1. It's minus 1. When you add that 2 to it, it will be plus 2. Then you have ARC plus R. So it is now the same thing with what we have here. So the next thing is to take out the coefficient of x raised to power c plus r. So I'm taking out the coefficient of x raised to power c plus r from the first one, from the first equation, which is this, that we just wrote here now. It is what we just wrote here now. So we're going to write it out. We have AR plus 2. Remember, it's a subscript. A sub R plus 2, C plus R plus 1. This is what we have from the first one. Then plus the second one is minus. So we have minus AR, A sub R, C plus R, C plus, C is only C plus R that we have for the second one. Okay, C plus R, and we have C plus R minus 1. So that's what we have for the second one. And for the third one, we have minus 2 AR C plus R. For the third one, plus AR K square. And for the fourth one, we have A plus AR K, all everything equals to 0. Okay, let's continue. From here, we can now continue solve further. So we have R sub A sub R plus 2, C plus R plus 2, C plus R plus 1, minus AR is common. AR, AR, AR. So if we factorize AR out, we are going to have C plus R, C plus R minus 1, minus. Now, we've taken out minus, so this one is going to be plus. When you factorize, this is minus, 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 minus. Now we've taken out the minus, so all the sign will change. So this one is going to be plus 2. We're taking out AR, C plus R. Then this one is going to be minus. AR is out, minus K square minus K, all equals to 0. Now let's carry all this to the other side. You're going to have A sub R plus 2, C plus R plus 2, C plus R plus 1 equal to AR C plus R, C plus R minus 1 plus 2 C plus R minus K square minus K. Now what we have here, you can see that from here to here, they have something in common, which is C plus R is common. So it's going to remain, when you factorize C plus R, so it's going to remain C plus R minus 1 here. When you take out C plus R, so you're going to remain only 2. Then you close the bracket, square minus K. You have AR plus 2, C plus R plus 2, C plus R plus 1. Now divide both sides by this, we have AR plus 2 equal to, so we have bracket C plus R, then this one will be C plus R plus 1, because we have minus 2 plus 1, we have minus 2 plus 2, that's plus 1, minus K square minus K square minus K, all over C plus R plus 2, C plus R plus 1. Now this is going to be our equation. Now let's call it, you can call it equation star. Now when C equals to 0, the first C that we obtained, we're going to have A, so it's R plus 2 to equal to AR is 0 plus R, so we have only half here, Then this one is going to be 0. So we have again to have c plus r plus 1 here, r plus 1. So again to have r plus or c is 0 minus k square minus k over this one is going to be r plus 1. Let's carry this one. No, it will be 0 plus r. So r plus 1 is the lowest. Then you have r plus 2. So it's 320. Now, to make the work easy, because we are using quadratic equation, let's factorize the minus out. We have minus ar. So you're now going to have k squared plus k minus r plus 1. Like to make it easier for us. So then we have r plus 2 was 1, r plus 2. To make it easier, this is minus, this is minus. Because we'll be using quadratic equation. So we take out the minus, so we have this. So we now start. Remember, in this case now, our a1, where a1, we have a1 equals to a3 equals to a5 equals to a7 all equals to 0 here. So let's find when c equals to 0, we have r is equals to 0. When if r equals to 0, so we have a2. I hope you remember how to check whether these are correct. Go back to your equation. When you come here, you can see that the coefficient that we have is c for a1 in this first equation. The coefficient is x squared c minus 1. If you check, it is only here that we can find x squared c minus 1. So definitely a1 will be 0. That's how to check. Let's move on. So now a2 now, it will be minus, because we are using this one, minus a0 in brackets of, if I put 0 for r here, everything is going to be 0. So you're going to have k squared plus k over 1 times 2. So which is minus a0 k plus 1. When you factorize k out, we're going to add that. So we have 1 times 2. Now for when r equals to 2 now, so we're going to have a4 in brackets of minus a2, sorry, minus a2 k square plus k minus, you have that will be 2. 2 plus 1, 2, that's 3 times 2, we have 6. We have 6 here. 2 plus 1, 3. 2 plus 2, 4. Now we'll be solving this separately. We have k square plus k minus 6. Let's solve this quadratic equation. So it's going to be k square plus 3k minus 2k minus 6. K is common, so it's going to be k plus 3. Here is going to mean, sorry, we factorize minus 2 out, so we're going to have k plus 3. So k plus 3 is common, then it will mean k minus 2. So when you solve this, you're going to write this, so you're going to write it here. So it now be minus a2. So this one is k plus 3, k minus 2 over 2, 3 times 4. So when you substitute this, because this is a2, this is what we have for a2. When you substitute here, so you have positive a0. So we're going to have k plus 3, k plus 2. So k plus 1, then we have k minus 2, k all over 1 multiplied by 2, 3 multiplied by 4. This is what we are going to have. This is what we are going to have. Now, let's move on. We have A6 now. Do we need to find A6? Now, let's stop at A2. You can find when R equals to 4. You can get that. You can find it. And let's move to the next one. Now, we now have when C equals to 1 now. There is something that is going to happen here. When C equals to 1, we're going to find it in terms of A1. In terms of A1. We're going to find it in terms of A1. No, this is our equation. This is the equation that we are using. We have this is the equation. A substrate R2 equal to minus R. Okay, F C plus R, C plus R plus 1, C plus R plus 1 minus K squared minus K all over C plus R plus 2, C plus R plus 1. This is what we have. Now, when we put in, when we now put in 1 into this, we have AR plus 2, AR, R plus 1, R plus 2, minus K squared minus K over R plus 3, R plus 2, when you put in R. So, which we can take out the minus. So, if I take out the minus, we're going to have minus AR K squared plus K minus R plus 1, R plus 2, all over R plus 2. Let's rearrange the denominator, R plus 3. Now, this is what we're going to have. When R now equals to 0, when R equals to 0, so we're going to have A2 to give us minus A naught K squared plus K minus 1. We have this because 0 plus 1 is 1, 0 plus 2 is 2, 1 times 2 we have 2, then 2 over 2 times 3. This is what we're going to have. We can see that if we do this, we are not going to get our this thing. We are not going to get it in terms of A1 because we have to get it in terms of A1. Now, what are you going to do? We can see that when we put in 0 into this equation, we do not have A1. So this is what we're going to do. We now go back to the equation of when C equals to 2, which we have minus AR K squared plus K minus R plus 1. Now, we now go back to this equation, R plus 1, R plus 2. This is the equation we're going to go back. Now remember that we said A1, A3, A4, A5, and A7 equals to all equals to 0, right? So this is what we are going to do. In order to get the second answer when C equals to 1 in terms of A1, we will now go back to this. So we now find the odd form of this, because when we solve this, we have this. You can see that we have A2. We started from 0 to, then you do for R equals to 4. So what we did here is that we look for the even part of it, because we said A1, A3, and A5, all the odd parts is 0. But if we do that, we are not going to obtain the second part in terms of A1. So in order to obtain it in terms of A1, we are going to go back to this equation. We are now going to substitute. We are not going to find A1. We are going to find A1, A5, and A7. When you find A3, A5, and A7, you will see that it will be in terms of A1, and the answer that you get, it will equivalent to the what you have here. I don't know, maybe you understand what I'm trying to explain, but let's do it. Now when R equals to 1 now, so this is the odd part. It will give us, we're going to have A3 to equals to minus A1 in brackets of K square plus K minus, this is 2, so we have minus 2 over 2 multiplied by 3. You can see that when C equals to 1, this is what we have in terms of A naught. This is what we have. You can now see that this and this are they not the same? They are the same, but this is when C equals to 0. When C equals to 0, so you're going to find 1, 3, 5. The 1, 3, 5 of here is equivalent to the 2, 4, 6 that you're going to find here. I hope you understand like that. You can see that what we have here, when C equals to 1, we have this. Is equivalent to when C equals to 0. So we now find 1, 3, 5, the odd part of when C equals to 0, be equivalent to the even part when C equals to 1. So that's it. But when we now solve this further, we're going to have, when you solve it using, do I need to solve it? K squared plus K minus 2. If I solve this, I will have K squared plus 2K minus K minus 2. K is common, so you're going to remain K plus 2 minus 1, K plus 2. So you're going to have K plus 2, K minus 1. So this is what we are going to have. So it means we have minus A1 in bracket of K plus 2, K minus 1 all over 2 times 3. Now when R equals to 3 now, remember the formula we are using is when C equals to 0. So this is the formula we are using now. So we have A5 to equals to minus A3 now in bracket of K squared plus K minus 3 plus 1, we have 4 times 5 times 3, we have 12. Is it not 12? 3 plus 1, 4, and this is 3. 3 times 1, 3 times 4, that's 12 over 3 plus 1, we have 4 times 3 plus this, we have 5. Now let's solve this. K squared plus K minus 12, that's K squared plus 4K minus 3K. 4 times 3 is 12 minus 12. So I have K k plus 4 minus 3 k plus 4. So k plus 4 is common. K minus 3. So this is going to be minus a3 k plus 4 k minus 3 over 4 times 5. So when you put in a3, this is a3, we have a3 give us minus a1. So it will now be positive a1 multiplied by, so you're going to have k plus 4 k plus 2 k minus 3 k minus 1. That is what you're going to have. This k plus 4, then you carry this minus 3, then you carry this all over. You're going to have 2 times 3, 4 times 5. That is what you're going to have. So as our a5 here. So the next part is to substitute what we have into the equation. When you do substitution, so we have y equal to x raised power c. For the first one, we have a naught plus a2 x squared plus a4 x raised power 4 plus the other. Now x raised power 0 now, because the first one is x raised power 0. This is what we have. So we have a naught. Now a2 is minus a naught k plus 1 over, we have 1 times 2, so we write it as 2 factorial x raised power 2. The second part is positive, so we have plus a naught k plus 3 k plus 1 k minus 2, then we have k x raised power 4 all over. So if you check the last one, we have, this is what we have, 1 times 2, 3, 4. So we can write it as 4 factorial. Now for the second one, when c equals to x raised power c now, we find it in terms of a1. So we have a1 x plus a3 x raised power 3 plus a5 x raised power 5. Now x raised power 1 now. So the first one is sorry, before we go, let's finish this one. So we can see that a naught is common, x raised power 0, a naught is common too. So we have 1 minus k plus 1 x squared over 2 factorial plus k plus 3 k plus 1 k minus 2 k x raised power 4 over 4 factorial. So this is what we have for the first one. Now for second one, y equals to x raised power c. So you now find it in terms of a1. So plus x raised power 3 plus a5 x raised power 5 and so on. So x raised power 1 now, because our c is 1. So we have our a1 is a1 x is constant. Now a2, what we have for a2 is a3 is negative. So we have minus a1 k plus 2 k minus 1 all over. So we have 2 times 3. So we can write it as 2 times 3. So we can write it as 3 factorial plus the second one. So x raised power 3 here. The second part we have a1 k plus 4 k plus 2 k minus 3 k minus 1 x raised power 5 all over. So we have 2 times 3 times 4 times 5. So we can write it as 5 factorial. So which is going to now be a1 x raised power 1. X raised power 1 is written as x. So x is, we factorize a1 now. So it's going to be x k plus 2 k minus 1 x raised power 3 over 3 factorial plus k plus 4 k plus 2 k minus 3 k minus 1 x raised power 5 over 5 factorial. So the final answer is going to be in form of u plus v. So our u is the first one that we obtained. So it's going to be, remember, we have x raised power 0. This is the first one that we obtained. X raised power 0. So x raised power 0 is something else, a naught. So you're just going to write, because x raised power 0 is 1. So a naught 1 minus k plus 1 x squared over 2 factorial plus. So let's follow the order k minus 2 k plus 1 k plus 3 x is power 4 over 4 factorial minus the other one. So now plus a1x. So we have x minus k minus 1 k plus 2 x is power 3 over 3 factorial plus k minus 1 k minus 3 k plus 2 k plus 4 x is power 5 all over 5 factorial minus the other one. So this is going to be our final answer. So now say where a naught and a1, where a naught and a1 are the usual arbitrary constants. So these are arbitrary constants. Thank you for watching the video. If this is your first time, subscribe, like and follow.